Now let's consider this problem where this is the Mealy machine given, and now I have to convert it to the Moore machine. So if this is the Mealy machine given, always start with the initial state capital A. And interestingly, in this we have an incoming edge on which we have an output, right? So what does capital A do on 0? Capital A on 0 is going to capital A and it is going to output 0. Therefore I am going to associate 0 with A, and capital A on 0 is going to capital A and is going to output 0. So it is okay. See, you can even write this as capital A comma 1, and you can create one more state as capital A comma 0, and on 0 you can give a transition. That is not a problem at all, right? But then this is simple, we can go with it. Fine. Next thing is capital A on 1 is going to capital B and the output is 1. Therefore I am moving the output here. So I created a new state capital B comma 1. So capital B is the state and output associated is 1. Fine. So this one is complete. Capital A comma 0 state is complete because I have shown what happens on 0 and 1. Now on capital B we have to show what happens on 0 and 1. See this, capital B on 0, capital B on 0 is going to capital B itself and the output is 1. Therefore capital B on 0 is going to capital B itself and the output is 1. Now capital B on 1, capital B on 1 is going to capital B itself, but the output is 0. Therefore capital B on 1 is going to capital B itself, capital B on 1 is going to capital B itself, but the output has to be 0. Therefore one more new state is formed. This state is complete because we have shown what happens on 0 and what happens on 1, but this state is not complete because we didn't show the transition set. What happens for capital B on 0? Capital B on 0 is going to capital B and the output has to be 1, which means capital B on 0 is going to capital B and the output is going to be 1. So that is how we got it as 1 here. Okay. And what about 0? What about 1? Capital B on 1 is going to capital B itself and the output has to be 0. Capital B on 1 is going to capital B itself and the output is 0, and this one is also complete, right? So what is this problem? This problem is nothing but we are going to read a string from the RHS and we are going to print the 2's complement as output. We are going to start from the RHS or least significant bit and we are going to print 2's complement. The main difference between Mealy machine and Moore machine is, in Mealy machine, if I have n inputs, which means if I give 0 0 1 1, then I'll get n outputs, each one for each. Let us say the answer could be 1 1 1 1 1 0, let us say 1. This could be the answer. If there are 4 bits, I get 4 bits as output in case of Mealy machine. But the problem with Moore machine is, if there are 4 bits, if I give 0 0 1 1, I might get 5 outputs. That is the problem. Therefore you cannot exactly say that this is exactly equivalent, but then it can be mimicked. What my intention is, it can give us some part of answer. Therefore both are equivalent, but only problem is Moore machine is going to generate one more input compared to the one more output compared to the Mealy machine. One point worth noting is, when we are constructing or converting Moore machine to Mealy machine, number of states doesn't change. Number of states didn't change when we are converting Moore machine to Mealy machine, but when I am converting Mealy machine to Moore machine, number of states increased. Okay, and how much it increased? If initial Mealy machine contains capital N number of states, and if the Mealy machine is outputting capital M number of outputs, then the final Moore machine may contain capital N into M number of states. So in the worst case, I might go up to capital N into M. In the worst case, I might go up to 4 states here, because 2 states are there. In the Mealy machine there are 2 states. and the outputs are 2. Therefore I might go up to 4, but in this case luckily we got only 3, right? So in any case we are going to go up to n into n states in the final Moore machine, right? This is the example.